In this video we're going to look at Vector, which is a log aggregation tool that's used to collect logs from different sources and then optionally perform some transformations on those logs and then output the results to different destinations or sinks. And an example of this might be to take logs from a file on the Linux file system and then transform those logs by enriching them with some new content before finally sending those logs on to BetterStack where they can be centralized and analyzed. And we're going to look at that exact use case in this video where we take logs from a custom application. We then perform some transformations on those logs and then send them to BetterStack where they can be consolidated. So Vector gives you a powerful platform in order to take those logs from different sources, transform them and then send them on. And it also gives you a Vector Remap language, and this is a powerful language that you can use for your log transformations. We'll see examples of all of that in this video, and before we get started, if you're enjoying this content, give the video a thumbs up and subscribe to BetterStack for much more. Now let's dive in. So let's start with a look at the Vector website. We can see that Vector is a lightweight, ultra-fast tool for building observability pipelines. And if we scroll down further, we get a kind of diagram of what Vector does. And there are three components to this diagram. We have on the left-hand side the sources. In the middle we have transforms, and on the right-hand side we have what's called sinks. So what Vector is going to do is collect the logs from the different sources that you set up, and you can optionally pass those logs through different transforms. And then on the right hand side, the collected and transformed logs can then be shipped to different destinations that are known as sinks. So as an example, you might have logs that are being output into a file. You might then collect those using Vector, transform them in some way, and then send them on to a different location, which could be something like Amazon S3 or Elasticsearch, Prometheus or BetterStack. So why would you use Vector? Well, first of all, it's ultra fast and reliable, and it's built using Rust. And Vector also supports logs and metrics, and this makes it easy to collect and process all of your observability data. And Vector also contains programmable transforms, and that gives you the full power of programmable runtimes, and you can handle complex use cases using this. And Vector is an end-to-end platform, and it strives to be the only tool that you need to get observability data from A to B, and you can deploy that as a daemon, as a sidecar, or an aggregator. So different deployment strategies for Vector. And there's a couple of extra points here. What we're going to do to start with is install Vector onto a Linux distribution, and then we're going to create a couple of different sources of logs from which we want to use Vector to collect those logs, transform them, and then send them on to a centralized location for analysis. And that centralized location later in the video is going to be BetterStack. So let's get started with that. I'm going to go on the documentation here to the installation page. So let's go to the Vector docs, and we're going to leave links to all of these pages below the video, as well as to this BetterStack guide where you can learn more about collecting, processing and shipping log data with Vector. So let's go to the logs, and we're going to go to the installation section, which is here on the left hand sidebar. If we click that, we're taken to this page here. Now Vector, it compiles to a single static binary, so it makes it very easy to install. And on Unix systems, the only dependency for Vector is libc. Now if we scroll to the bottom of this page, we have some other installation methods for Vector. And what I'm going to do is install this on an Ubuntu distribution on Windows Subsystem for Linux using a package manager. So let's click the package manager, and we're going to use apt. So if we click the apt button, we're going to be taken to the page on installing Vector using apt. And this is a standard package manager for Debian and Ubuntu and other Linux distributions. Now let's scroll down to the installation section here, and we're going to copy these commands and we're going to use them inside the terminal. Now the first command here is to add the Vector repo. So we're going to copy it and we're going to paste that into our terminal and execute that. And once that's finished, you can see at the bottom here that the Vector repository has been set up. And what we can now do, if we go back to the documentation, is install that using apt-get. So let's copy that command and go back to the terminal, and we're going to paste that in and install Vector onto this Linux distribution. Now once that's completed, we can clear the terminal, and we're going to check the status of Vector now. So we can use systemctl to do that, and we're going to check the status of the Vector binary. So let's run that command, and we can see that at the moment Vector is inactive. So in order to start Vector, we can use a different noun here, and that's the start noun. And once we've started Vector, we can rerun the status command, and this time you can see that Vector is now active, it's running in the background. We know that it's been installed on this system. Now for this video, I'm actually going to stop Vector from running as a background daemon, and we can do that with the systemctl stop command. We're actually going to manually run Vector in this video to avoid any conflicts with the background process. So now that Vector is installed, we're going to start using it on this Linux distribution. Now I'm going to go to the BetterStack guide on Vector here, and we're going to go to one of the sections on the left hand side, and it's this one here on how Vector works. Now we have this diagram that we saw on the Vector documentation, and again we have sources on the left hand side that define where we want to collect logs from. So we have sources, and then those sources can optionally go through some kind of transforms. For example, you might parse the incoming logs to a different format like JSON, and we can also sample and aggregate the logs, and we're going to see examples of that later in the video. And finally, we output the logs to a sink or a destination. And those are the three component types that you have in a Vector setup, and each component requires you to specify a plugin. And we'll see these plugins in a second, but let's look at this paragraph first. To understand Vector, you can imagine it as a pipeline. So at one end, Vector will ingest raw logs and it will standardize them into a unified log event format. And then as that log event travels through Vector, it can undergo various manipulations using these transforms to manipulate and enhance or enrich the content. And finally, at the end of that pipeline, the log event can be sent to multiple destinations for storage or analysis. And we define these sources, transforms, and destinations in a configuration file called vector.yaml. We're going to see examples of that very soon in this video. And what we're going to do in this video is define two sources. The first one is going to be the syslog file on our Linux distribution, and the second one is going to be a custom application. In our case, it's going to be a Python FastAPI application that's going to generate some logs that we want to then capture using Vector, perform some transformations, and then store those logs centrally using BetterStack. Now that's coming up later in the video, and that will be Python based, but these concepts will work with any type of application. So we're going to start by looking at the syslog file on our Linux distribution. So let's go back to the terminal, and the syslog file is in the /var/log directory. Now once we're in that directory, we can list out the contents of the directory, and we have the syslog file down here. And what I'm going to do is use the tail command, and we're going to get the last 25 lines from that syslog file. So let's execute that command. Now we have output from different services such as the Linux cron daemon, and we can also see some output from systemd here, and these apply to actually starting and stopping Vector as we did earlier in the video. Now what we want to do is collect the logs from this syslog file, and we want to then send them to a different location, a sink, using Vector. So the syslog file that we just looked at is going to be the source, and we're going to configure a sink in order to send the logs on to a different location. Now in order to do that, we need to go to the Vector configuration file, which is in the /etc/vector directory. And if we list out the contents of this directory, we have a YAML file here, and this is the main configuration file for Vector. Now we can take a look at that file, and in fact we're going to edit that file, so let's use nano to do that, and it's the vector.yaml file. And let's have a look here at what we have in this file. So we can see we have a block for the sources that we define for Vector to collect logs from, and we have a source called dummy logs in the default setup. Below that we also have some transforms, and what we have here is a transform that we've called parse logs that uses the remap type, and we're going to see an example of remapping later in the video. And finally we have a block for the sinks, and this block is going to define what happens to the data that's flowing from a particular input. In this case it's from the parse logs transform above, and that transform in turn will take the input from the source called dummy logs that we have at the very top of this file. So what we need to do now is define our own workflow where we're going to create a source that looks at the syslog file, and we're going to output that to a particular sink. So what I'm going to do to start with is get rid of what we have by default in this file, and we're going to start from scratch. So we've now removed that configuration, and we're going to add our own source, our own transform, and our own sink. So let's start with the source. We're going to add a source that we're going to call syslog file, and this particular source is going to come from a file on the file system, so we're going to give it a type of file. And because it's a file, we need to tell Vector where to actually retrieve the logs from. Where is that file on the file system? So we're going to use an include block here, and we can use a list here in YAML, and the file is going to be /var/log/syslog. So that's going to be our source. We don't actually need a transform for this part of the video, so I'm going to remove that, and we can define a sink just below here. Now the sink will define where the collected logs from the syslog file are going to be sent after they've been processed by Vector. And before we add that configuration, I want to go to the Vector documentation, and we can see some of the available syncs that we can use. So for example, we have various syncs for AWS services like CloudWatch Metrics and CloudWatch Logs. We have syncs for S3, we have syncs for Azure Blob Storage, as well as other services like ClickHouse. And we also have a console sync that's going to display the events in the console. We're actually going to use that in a second. But if we go down, we have many other ones. We can send the events into new files. We can send them to Elasticsearch. We can send them over the network to an HTTP endpoint. And we have many more of these as well. Now the one we're going to look at is the console sync. So let's click this here. And this sync is useful for debugging purposes. So let's look at the YAML configuration for the console sync. All we need to do is define a name, and then we give it the type of console, and we need to specify the inputs for this sync. So let's do that now. If we go back to our vector.yaml file, let's give the sync a name of print, and we're going to give it the type of console. Now we need to also specify the inputs for this particular sync, and we're going to add this source that we had above into this list, and that's going to be the only input for this particular sync. And finally, let's add an encoding of JSON here. So we'll have an encoding block, and we're going to set the codec to JSON. Now let's save this vector.yaml file, and we're going to go back to the terminal. Now there's a command that Vector provides, and that's the vector validate command. So let's run that, and we get back that output there, and it looks like all is good. The vector.yaml file has been validated. So let's quickly take one last look at vector.yaml. We've added a source that's going to look at this particular file, the syslog file on the Linux distribution. And we've set up a sync here to take the output from that particular source, and that's just going to print the logs directly to the console using this console sync type. Now we can test this out by running the vector command, and I'm going to run it like this with the sudo command, and you can see that all of the logs from the syslog file have now been redirected, and they've been sent to the sync that we've configured. In this case, that's the console. Now you can imagine this being useful if you have a system with a lot of logging in different places. You can use Vector to look at all of those sources, and you can have a common configuration about where you actually want to send those logs to, whether it's somewhere else on the file system or a remote service such as BetterStack or Elasticsearch. So that's how we can take a simple file on the Linux file system, collect those logs with Vector, and send them on to a sync. What we're going to do now is look at logs that are generated by a custom application, and we're going to use the application that we built in a previous video, and that was the video on the rsyslog service that should be appearing on the screen now. Now you don't need to watch that video to understand what we're about to do now. We're going to explain everything, but what we need to do first of all is go to the application that we created in that video, and that was a Python FastAPI application. So I'm going to go to that directory now. So I'm in that directory now, and we've activated the Python virtual environment. And if we look at the contents of this directory, we have an api.py file that contains our FastAPI application, and we also have an app.log file. And this file is where the application is sending the generated logs to, and we can see that better if we open up VS Code in this directory. So what we have here is our FastAPI application in the api.py file, and we create a logger object in this file, and we're creating a file handler that points to the app.log file. And finally, we have a formatter that's set to the JSON formatter here, and that comes from the Python JSON logger package. So we add that formatter to our handler, we add the handler to the logger object, and we're setting the log level to the info log level. Now once we've done that, it's very simple. We have a FastAPI application, and we have a single endpoint at the default route, and that endpoint is outputting some simple data here. So we have a Python dictionary containing the IP address of the client, and also the request method. In other words, is it a post request or a get request, and so on. And finally, the endpoint uses the logger.info method, and we're outputting this simple message, request received, and we're adding that dictionary of data as the extra keyword argument. Now what I'm going to do is go back to the terminal here, and we can start this FastAPI application using the uvicorn command. And our app object is in the api.py file, and it's called app. So we can start the server with this command, and that means that on localhost 8000 we're going to actually hit this endpoint here and generate the logs. So I'm going to do that now. If we open the browser and we refresh this page a couple of times, if we then go back to VS Code and look at the app.log file, we can see the JSON output from the logs that are generated by this FastAPI application. So what we want to do is use Vector to actually collect these logs, and we want to send it to a destination sync, and we're also going to perform some transformation on this log output, as we're about to see in the video. So let's start collecting the logs. If we go back to the terminal, I'm going to stop the 𝗖𝗵𝗽𝗀 server, and we're going to go back to the directory where our vector configuration lives, and that's /etc/vector. So let's go to that directory and we're going to list out the contents. And again, we have this vector.yaml file, so let's use the nano command, and we're going to again change this file, and we're going to add a new source to the file. And that source is going to be the log file that we just saw for our custom FastAPI application. So let's configure the new source. I'm going to call this FastAPI. And again, the type of this source is going to be file. And again, we need an include key here that's going to point to where the file actually is on the Linux file system. So let's paste the path in here. And if you're following along, you can specify whatever path makes sense on your file system. And that's all we need for a FastAPI source for the file where those logs are being generated. We're now going to configure a sync, and that sync is going to take the logs from our FastAPI application. And all we're going to do to start with is output those to a new file on the file system. So let's go back here to the syncs section, and we'll create one that I'm going to call FastAPI sync. And again, the type is going to be equal to file here, and we need to specify the inputs for this particular sync. And we're going to look at the FastAPI source that we configured above, and that's going to form the input for this sync. Now we're using a file sync here, which means that we're going to take the logs from the given source and we're going to send them to a file on the file system. So this is slightly different from above, where we just outputted the logs to the console. What we're going to do now is we're going to configure what file we actually want to output the logs to. And we can do that with the path key. And let's say we wanted to output to the var log directory, and let's give it a file name of application.log. So what we hope to happen here is that we're going to collect the logs from this app.log file, and we're going to forward them on to this directory here and to that file within that directory. And again, I'm going to specify an encoding here, and we're going to set the codec to JSON. Now for now, let's get out of this program and we're going to save the file. And let's clear the terminal, and we can run the sudo vector command, and we get the output from the syslog file. But what we want to do is we want to check whether that new file has been created. So again, let's cat out the vector.yaml file, and it's this file here, the application.log file. We want to check whether that file has actually been created in the /var/log directory. So let's go to var/log, and in this directory we can list out the contents, and we can see that an application.log file has been created, and we can look at the contents of that file using the cat command, and it's the application.log file. Let's execute that, and we get back the output here. So Vector is working fine here. It's collecting the data that's generated by our FastAPI application, and it's forwarding that to a centralized source, in this case the var/log directory on Linux. We're now going to learn about the vector remap language, which allows you to perform transformations of logs between the source and the sync. And to learn more about that, we're going to go back to the BetterStack guide on vector, and we're going to go to this section here on transforming the logs. Now it's uncommon to send logs without processing them in some way. So for example, often you need to enrich your logs with important fields, and on the other hand, sometimes you need to redact sensitive data from your logs, and often you need to transform text-based logs into a structured format like JSON. Now Vector offers a powerful language for data manipulation, and that's the vector remap language, and you'll also see that called VRL. And this is a high-performance, expression-oriented language designed for transforming data. It provides functions for parsing data, for converting data types, and it even includes conditional statements and other capabilities. Now if we scroll down here, we can learn about the dot operator in VRL, and we're going to see how we can access an entire log event using that dot operator, and also how we can access individual fields in the logs. And in order to do that, we are going to use the vector VRL subcommand, and that will start a REPL that you can then interact with on the terminal. So let's do that now. We're going to copy the vector VRL command, and I'm going to paste that into the terminal here, and we're going to point it at this application.log file that's been generated by Vector. So let's clear the terminal, and we're going to run vector VRL, and we're going to pass an input file here of application.log. Now remember, that's the JSON file that was created by Vector when it collected the logs from our FastAPI application file and then sent them on to the sync that we configured, which was the application.log file. What we can do is we can just type the dot, and that's the main operator in VRL, and we get back this output here that represents a single log event from the given log file that we passed in, which was application.log. So the single dot is just going to print out a log event, and what we can do, if we look at the structure here of these log events, we have individual fields such as file and such as host, and other ones like the message and the timestamp. So let's imagine that we wanted to extract the timestamp using this vector remap language. To do that, we can type the dot and we can type the name of the field, which is timestamp, and that's going to give us back the timestamp for that log event. And we can do this for the message as well, and we're going to see that this is a nested field here. So when we access the message here using .message, you can see we get a JSON string containing that nested message. Now, one thing we can do with the vector remap language is take this nested string for the message, and we can actually parse that as JSON data. And that's going to convert that to an actual nested object where we can then go and access the keys within that object. So let's see an example of that. And before we do, let's go back to the documentation for vector. And I'm on a page here for the vector remap language, and this is a page that lists out all of the available functions in VRL. And it starts with this one here, parse Apache log. So if you're using vector to parse the content in an Apache log file, this particular parsing function is useful for that. And there's lots of functions here in this module. We also have functions for parsing CSV files, parsing JSON content and XML content at the bottom here, as well as parsing timestamps and syslog messages. And of course, as well as Apache, we can also parse Nginx logs as well. So a lot of flexibility in vector to extract data from particular log formats. What we're going to use is the parse JSON function here. So let's click that, and we can pass in a string here which represents the JSON that we want to parse. And that's what we're going to do with this nested message that we see here. Now, the reason that we want to do this is because we might be interested in these individual keys in the nested object. So if I wanted to get the level name from the message, we might expect to be able to use this syntax here, but that's going to return null. And that's because this whole message here is a string. We can't extract that information at the moment. Let's try using this parse JSON function, and we're going to use an exclamation mark here. And then what we pass into that is the message. And let's see what this gives us back. This gives us back an actual object, and that object contains key value pairs, and we can then use that object to extract data. For example, we wanted to get the level name. If we access that, we get back info now, because the actual object that we have here has been parsed as JSON. It's been converted from that string to something that we can then access the individual keys within. Now, when Vector collects the logs from our FastAPI application, we want to perform this transformation on the message field automatically during that process. So we're going to need to add a transform to our Vector configuration file, and we're going to tell Vector that we want to do this in that transform. And there's one other transform I want to do, and that's to enrich the logs with some new data. So what we're doing here is parsing the logs and converting from a string to an object, but we can actually add new keys to the log output, and that's called log enrichment. So for example, if I wanted to add a key called from localhost, and that would be a Boolean key, true or false, how would we do that? So let's go back to the message that we have. If we look at the message, we have an IP address within that, and that's usually going to point to 127.0.0.1, and that's the localhost IP address. So what we're going to do is add a key called from localhost. Now, how do we get this IP address? We need to again parse the JSON content here for the message, and then we can access the IP address key within that nested object, and we get back the IP address here. Now, we want to perform an equality check here to check if it's equal to 127.0.0.1, and that's going to return true or false based on whether the IP address matches. So if we change that, it will return false. What we can do with this statement here is we can actually set a new key in the log output. So that key can be called from localhost. We can set that equal to that expression. If we execute that, we get back true. So that's how we would add that key to the logs. Now let's get out of this terminal here. So the VRL terminal, we can use the quit command to go back to our normal Linux terminal. And what we're going to do is go back to /etc/vector, and we're going to go to that vector.yaml file using our nano text editor. Now what we need to do here is add a transform, and we want to add a transform for the logs collected from this source here for our FastAPI application. So let's add a new block here called transforms, and I'm going to call this FastAPI transform. And for this transform, we need an input. So let's pass the inputs key here, and we're going to set that to a list again. And we need to specify what source we're going to use here for these transforms, and we're going to use the FastAPI source above. Now the transform also needs a type, and we're going to use the remap type here. And finally, we specify the source code for this transform. So what we're going to do is pass two statements in here, and the first one is the one that we just saw, where we parse the message from the log event as JSON content, and we're going to reassign the message key to the result of that expression. So that's the first expression, and the second one is going to set the from localhost key in the outputted JSON logs, and that's going to be set to this equality statement where we check the IP address and check that it's equal to 127.0.0.1, and these are going to represent the transforms for our FastAPI source. So let's save this file, and we're going to go back to the terminal and we're going to run the vector validate command, and we can see this interesting statement here that the transform FastAPI transform has no consumers, and that's actually a mistake that I've made. So let's go back to vector.yaml, and we're going to scroll down here, and what we're going to do is we're going to look at the syncs section, and the name of this transform is FastAPI transform. We need to set that here in the FastAPI sync. So the input to the sync is no longer going to be that FastAPI source because we've passed that source through a transform, and we want to set that transform here as the input to this sync. So let's do that now, and we're going to save the file, and again we can run the vector validate command, and this time all is looking good. Now what I'm going to do is generate some more logs by starting the FastAPI application and generating those logs. So we're going to restart the video after I've generated some new logs. So we've generated some logs. We can now run the vector command, and that's going to then output the logs to our application.log file. And remember, that was in the /var/log directory. So let's have a look at that now. And if we tail the application.log file that we have here, we're going to see the output from our vector process. Now something interesting to note, we can see the from localhost key, and that's set to true in this particular entry. So it looks like that process has worked. It's enriching the logs with an extra key where we can check, in this case, whether or not the request came from localhost. And what we can do is we can use that vector vrl command to go back to this log file, application.log, and we can check to see that the message has been parsed as JSON and that the from localhost key exists in the log entries. So let's use the vector vrl command, and we're going to point that to the application.log file. And if we look at one single log record, we can see that from localhost is set to true. And if we look at the message specifically here, we can see that this has been parsed as an object. It's no longer a string containing the embedded keys and values. That has been parsed, and we can now access individual keys such as the IP address on that object. So we've transformed the logs and we've enriched the logs with a new field. Let's now move on to the last part of the video. We're going to send these logs to BetterStack where they can be centralized, and we're going to use Vector in order to do that by configuring what's called an HTTP sync to forward those logs to BetterStack. Now what I'm going to do is go to this documentation on sending logs to BetterStack using Vector, and this is linked below the video. What we can do is we can go to the additional information section at the bottom here, and we can see how to configure BetterStack as a Vector sync. Now before we do that, we're going to actually log into BetterStack, and we're going to create a source on the BetterStack platform where we can actually send these logs to. So we're now on the BetterStack logs and metrics section where we can create a new source. So let's do that just now. We're going to click that button at the top right, and we're going to give the source a name of Vector Demo, and we can select the platform for these logs, and that's going to be from Vector. So let's create this source now, and what we're going to get back here is a source token. We're going to need that in a second. Now let's go back to this page on configuring BetterStack as a vector sync. What we're going to do is we're going to go to the vector.yaml file, and we're going to paste this transform and also the sync below into that vector.yaml file. So let's go back to the terminal, and we're going to go back to the /etc/vector directory, and let's run nano against that vector.yaml file. Now if we go down here, what we're going to do just under the transform section is we're going to paste that block of code in. So we've now added the BetterStack transform. Now we need to make one change to this. The input for the BetterStack transform, we're going to set that equal to this FastAPI transform that we had above. Now this goes back to what was mentioned in the intro. Imagine Vector as a pipeline, and in this pipeline the source is this FastAPI source that we set up from the app.log file. That source then goes to this FastAPI transform here, which enriches the logs with the from localhost field and also converts the message to an object. What we're going to do is we're going to set a new transform here, the BetterStack transform, to take the output from this transform above and use that as the input that we can see here. So let's set this equal to the FastAPI transform from above, And once we've added that BetterStack transform, we can go back to the documentation, and I'm going to copy the code for the sync, and let's go back to vector.yaml. And we're going to scroll down here and define a new sync in this configuration. So I'm going to paste that in here, and what we have is a new sync called BetterStack. And the type of this sync is HTTP, which means it's going to send the logs over the network to an HTTP endpoint. And you can see that endpoint's URI here. And that's the BetterStack endpoint for ingesting logs. Now you can see at the bottom we have a block called auth, and we have a strategy of bearer, and what we need to do is paste our source token into this section here. So I'm going to remove this string that we have here, and we're going to paste the token that we got back from BetterStack when we created the BetterStack source. So let's go to the browser, and we're going to go back to our page here where we created the BetterStack source, and we're going to copy this token. We can now go back to the vector.yaml file and paste that token in here, and that should hopefully be all we need to do in order to get this working and get these logs being sent from our Linux file system to BetterStack, where we can centralize and analyze these logs. So let's save the vector.yaml file, and what we're again going to do is run the vector validate function, and you can see that that has returned successfully. We can now run the sudo vector command to manually run vector, and again all of the previous pipelines are going to run as well, but this time hopefully the logs are also going to be sent to BetterStack over the network. So let's check that out now if we go back to the browser, and we're going to look at the live tail for our logs. And when we click that, we're getting back these log entries here, and we can examine the individual entries. And we can see we have keys that we added using vector. The from localhost key is set to true, and our message here, that has been parsed as an object, and that is now accessible. So we can actually access individual fields within that message because we have pre-processed our logs and transformed them using vector. So let's see a quick example of how we could do some searching over these logs. If we want to look at the from localhost field, we can filter the log entries where that is set to true using this statement here. So if we select true, we can see the statement at the top, from localhost equals true. We can then search through the logs to get only the logs where that statement applies. So that's easy log filtering that you can do on BetterStack. And because we've consolidated the logs in this nested message field, we can also look for logs with a given method or IP address, and we can do that by using the nested property. So let's look at the message, and then we can use that dot notation to access the nested fields on the message. For example, the method. We can check for all logs where the method is equal to get by using that statement here. And when we search for that, we're going to get back all of the logs because, well, they were all using an HTTP GET request. If we change that to something else like post, we're not going to get back any logs here. And that's because none of the requests that generated those logs were post requests. And we can go back to the live tail just to finish the video off. So that's all for this video. We've seen in this video how to use vector to collect logs from different sources in our infrastructure, and then how to transform those logs by parsing them from one type to another, and also enriching the logs by adding new keys and values to the log outputs. And then finally, we've seen how to take those transformed logs and then send them to various different syncs. And these syncs represent destinations where you can send logs from a variety of sources and consolidate them for analysis. And in this video, we saw how to configure BetterStack as our sync. And by doing that, we can get access to all of the logs with all of the different fields in those log outputs. And we can then search and analyze these logs on BetterStack very effectively in a central location. Now, if you have any other requests on vector or other topics that are similar, let us know in the comments, and make sure to give the video a thumbs up if you've enjoyed this content, and we'll see you in the next video.